Force here is the electric force. If they are like charges, like positive and positive or negative and negative, they repel. However, if they are unlike or opposite charges, then they attract. Now, concerning the effects of any force, it could be deforming or changing the shape and size of a body, as shown here in the figure, in which the chef is doing a force on the dough, changing its shape. And the second effect is setting an object in motion. Here, the man is pulling it in order to move it. And three, modify the motion of an object by increasing or decreasing its speed. The force exerted by the leg on the pedals while pedaling, causing the wheels to move faster, uh, or when the boy uh, does uh, press on the brakes and performing a force, causing the wheels to decrease or to speed down, decrease their speed. Or speed down, we say. So, four, modify the motion of an object by changing its direction of motion, like when the ball is moving towards you, then you kick it. Kick it means you are performing a force or exerting a force on the ball, changing its direction. Now, a note here, the point of application of contact forces is the point of contact between the actor and the receiver, and the point of application of forces acting at a distance is at the center of gravity of the receiver. Now, concerning a very important condition, which is the equilibrium condition. A body is said to be at equilibrium if the sum of all forces acting on it is zero vector. This means that it remains at rest. And when we talk about this condition, we can express it mathematically by sum of a vector equals zero vector. This implies that the sum of, if we are considering a two-dimensional system, reference system, this means that the sum of all the forces of all the horizontal components of the forces is zero, and the sum of all the y components of the forces acting on the body is zero. The principle of interaction, this is another idea here. If a body 1 exerts a force on body 2, then 2 exerts a force of the same magnitude and line of action but in opposite direction on 1. This is true for both contact and distant forces, and this is actually in Newton's third law, which is expressed as F vector 1 on 2 is equal minus F2 on 1 vector. I want to note here that we cannot express the same statement by saying that F vector 1 on 2 plus F vector 2 on 1 equals 0 vector. That's absolutely false, because we cannot add two vectors acting on different bodies. When I say 1 on 2, this means it's acting on 2, and when I say 2 on 1, this means it's acting on 1. So we cannot add these two vectors. That's why we only express it in this way, showing that they have the same line of action and opposite direction and same magnitude. And we can refer here. Here the man is trying to push the table, so exerting a force on it, a muscular force on it to the left. At the same time, the table is interacting and the man feels as if something is opposing its motion. So the table is exerting a horizontal force on the hand of the man to the right.